everyone. We're going to talk about probes today. How does an electrolysis probe work? Well, here's what happens. Electricity comes from that probe holder, like we just talked about putting this needle into it, comes from the probe holder. Electrons, they travel on the outside of the probe. Heat travels through the bulk of the probe. So what happens is your electrons come from the needle holder, from the wall to the needle holder to the probe. They travel along the outside of the probe, following the curve of the probe down to the narrow part of the probe, and then all the way to the tip. At the tip, they create what's often referred to as an electron cloud. Essentially, they make a cloud of electrons because they're coming off at the tip. And what that does is causes the various chemistries that destroy the follicle. Now, here's some thoughts about electrons. Number one, electrons, like cars going over a really steep hill, they can't jump corners. So that means that if at any time along the probe there are large corners, electrons can fall off. So for example, in a tapered needle, this edge, you're going to lose some electrons because it's a little bit sharper edge. Notice this taper is not steep, it's a gradual taper. That makes it a lot easier for the electrons that get from the larger end to the narrower part to move along them. And so then they concentrate on the needle all the way down to the tip. At the tip, inherently, there's a point. So all the electrons fall off at the point. With a thicker needle, you can imagine that the wider diameter of the point means that you'll have a wider diameter of the area of the electrons. So if you have a larger hair follicle, you want to use a larger needle diameter to make sure that the size of that cloud where you're doing the chemistry matches the size of your hair follicle. You could also imagine that if you have a very narrow tip and you have the same number of electrons coming to the tip compared to a very wide tip, in a very narrow tip, those electrons are concentrated. And so you're going to get a lot more chemistry happening there, which means you can end up with, for example, hot spots. Regardless of the size of the probe, there is always some of the work that goes out as heat, particularly if you're using RF, radio frequency thermolysis. There, you're literally creating heat at the tip. The issue is that metal is conductive. So it's conductive for electrons going from your needle holder to the tip. It's also conductive to heat. So as the tip heats up, the whole needle starts to heat up. But it moves from the tip all the way back. And it moves through the bulk. So it will move faster along the thinner part and slower along the thicker part. With that, thank you for watching. If you have any questions, feel free to reach out.